Analog signal transmission, amplitude modulation and frequency modulation. Amplitude modulation is when only the amplitude of the carrier wave is changed with the intensity of the signal. Both the positive amplitude and the negative amplitudes are changed in the carrier wave. Frequency modulation. In frequency modulation, the frequency of the carrier wave is changed according to the signal, as shown in the diagram. Where the signal has a positive value, the carrier frequency is increased. For example, in points B and F. But during the negative signal peak, for example, in the point D, the carrier signal is reduced. Multiplexing. Multiplexing is when multiple signals are combined together and traveled simultaneously in one link. There are three multiplexing methods: FDM, WDM, and TDM. Frequency division multiplexing. The FDM deals with analog signals, not digital signals. Users send their data over the same channel simultaneously, but each user has its own non-overlapping channel. FDM is mainly used in a broadband system. Time division multiplexing is when the multiplexer divides time slots for each user, and the demultiplexer at the receiver separates the data which is sent. All users are given the same time, which is not practical in situations where there is a high priority data, or when there is a huge volume of data. There is synchronous time division multiplexing and statistical time division multiplexing. In synchronous time division multiplexing, there is a synchronization between the multiplexer and the demultiplexer, so that the required channel or the time slot must be passed to the respective target channel. Time is allocated even if there is nothing to transmit, which can be a wastage. In statistical time division multiplexing, it analyzes which user has high priority data, or which user has more data to transmit, and it allocates more time for that particular user. The signal modulation methods include frequency hopping spread spectrum and the direct sequence spread spectrum. When listening to radio or watching a TV, there we tune into a fixed channel, which can face problems like interception. In FHSS, which is frequency hopping spread spectrum, this is solved because the signal within the frequency band is spread. The data will travel by hopping in different channels. The data is sent on one frequency at a time and uses different frequencies at different times. When this hopping is done, a pattern is created. This pattern is known only to the sender and receiver. This type of modulation is used mainly in the military. In direct sequence spectrum, the sender original data are passed through the spreading modulator, which when this is passed through the spreading modulator, where PN code is added and mixed at the center spreading modulator. PN code are much higher, is a much higher bit rate sequence. After mixing the PN code with the signals, it will be sent over a much wider bandwidth. At the receiver spreading modulator, the PN code is demodulated and the original signal is restored. Each bit is being encoded and the signals are more distributed over a large frequency band. This is the in the process of modulation and demodulation. There is transmission media, which is directly below the physical layer and controlled by the physical layer. It can be guided and unguided. Guided media has twisted pair, coaxial cable, and fiber optic cable. Twisted pair and coaxial cable signals in those are transmitted in the form of current, and in fiber optic it is transmitted in the form of light. Talking about the twisted pair cables, it contains two conductors with a plastic covering which are twisted together. Noise, if the two cables weren't twisted together and the signal and the two wires were parallel, it would have a higher effect on the noise, since one would be more close to the noise source than the other. But since the two are twisted, at the first twist, the first wire would have more effect on the noise than the second wire, and in the second twist, the second wire would have more effect from the noise than the first wire. So like that, at the end, the receiver can find out the difference between the two wires and cancel out the difference. So we can say that the more twist, there will be less and no interference from the noise in twisted pair cables. Fiber optic cable. Fiber optic cable is made from glass or plastic and transmits signals in the form of light. Optical fibers use the reflection to guide the light through the channel. The glass or plastic core is surrounded by a layer of less dense glass or plastic. The light beam which is traveling through the core is reflected off the cladding. Fiber optic cable can be in single mode or multi-mode. Multi-mode is when multiple beams move through the core in different paths. Single mode is when a highly focused source beam of light is traveled. Unguided media. Radio waves. Electromagnetic waves ranging in frequencies 3 kHz to 1 GHz are normally called radio waves. Radio waves are omnidirectional, which means they can travel in any direction. Radio waves can travel a long distance and can receive signals inside a building. But one problem in radio waves is that it cannot be contained. When transmitting data, the data can be corrupted or lost along the way, or the data which is sent by the sender may not be equal to what is received at the receiver. The types of errors can be single bit or burst error. Single bit error is when only one bit is changed, and burst error is when more than one bit has changed. Errors can be corrected using many ways. For example, forward error. Forward error is when the receiver guesses what the sender is trying to say. Or retransmission, when the receiver asks the sender to retransmit the data again. And checksum, when for example, if the sender sends a few numbers, the total of the numbers is the receiver checks if the total of those numbers is equal to checksum of the total of those numbers in the sender. Like that, there are a few ways of preventing or correcting the errors which occur. Multiple access protocols include random access protocol, controlled access protocol, and channelization protocols. Under channelization protocols, we have FDMA, which is frequency division multiple access, which is where the available bandwidth is divided into frequency bands. Each station is given a band where only that particular station can use. All the bands given are separated from each other. TDMA,